Okay, but if you want to use a bigger scoop to get more confidence, right? So we could raise our confidence without the downsides of making a stupid interval that's useless. So if you want to do that, that's all well and good, fine. But the problem then is how big a scoop? So you've got two issues. Problem. Here, let me put it this way. Problem number one, someone needs to pay for the scoop to get taken in both time and money. I don't know if you've ever tried to call 100 people and ask them questions. They tend to hang up on you. They tend to not want to talk, right? And you got to pay somebody to sit there and make those calls. And who's going to pay for the phones? I mean, making one phone call is fun, but when you're trying to call 300 people in a night, 500 people in a night, that takes time. That takes money. Who's going to do it, right? Problem number two. Right? I can't remember what problem number two is. Oh yeah, I remember now. How large is large enough to get the accuracy, i.e., margin of error, that we want? That's kind of a big question. I mean, you can't just go off half-cocked and figure out what you want. You'd be like, give me people until I feel like stopping. No, no, it's not how it works, right? You have to tell people, okay, I want 100 people to poll. I want 1,000 people to poll. I need to figure all this out ahead of time. Nobody's going to give you money to conduct a poll if you don't know who the heck you're talking to and how many, right? So, if you were a statistician or if you, I don't know, suppose you were asked by your boss to run a survey, that kind of thing. How do you really raise confidence? And the answer is it sort of depends. It depends on time that you have available, the money you have available, the resources, the personnel. Do you have people that kind of know what they're doing for asking questions, or would you have to train them first? I mean, all these factors and many other factors need to be balanced out. So there's no one right answer to that. Alrighty then. Okay, suppose when you were sitting in my class, your two nearest neighbors also had scoops of 120 beans. Also, I guess that's a little bit of a typo. Alright, so I'll just delete the second also. Alright, one has an interval that's 30.8% plus or minus 8.3%, and the other has 18.3% plus or minus 6.9%. Write out each of these in interval notation. Okay. So I'm just going to bring up my handy dandy Excel here. Make Excel do this. So, let's see. I need 30.8 minus 8.3. I need to turn on my numberlux key is what I need to do. Come on. Equals 30.8 minus 8.3. There we go. Equals 30.8 plus 8.3. There's one of them. And then I need 18.3 minus 6.9 and 18.3 plus 6.9. Alright, so let me just copy and paste these in here so that I can write it down. Okay, so I had 22.5 comma 39.1. That's one of them. And 11.4 comma 25.2. 25.2. I'm typing without looking, you can tell. Alright, so then if we graphed those on the same axis as ours, so here's yours right there, and notice it goes from about 17.2 to about 32.7, and then here's the next one, 22.5 to about 39.1. There's the next one, 11.4 to 25.2. See how they're there? They're just kind of tilted on their side from what we drew before. So as it turns out, the true proportion for the box was actually 20%. Okay, so draw a solid line representing that value. What do you notice and how can you conclude? All right, hold that thought. All right, there it is. See that? That's what it really was for that box. It was really 20%. Now notice, not all the intervals contain it. This neighbor, whoever he was or she was, doesn't have 20% inside their interval. All right, let's pick up here next time.